Morning class. Okay. So this is the week 13. Okay, this is week 13 topics. So we will look at the numerical part for solving the PDE. Okay, so we will look at two finite difference methods. One is for parabolic equation for heat equation, and another one for wave equation. Okay, so today we look at the one for the heat equation. Okay, now this is the big picture for solving a second-order linear PDE. So you have learned the analytical methods, which is the separation of variables. Actually, you just learned this one. Okay, there are other analytical methods. Okay, where you will get an exact solution. Okay, the true solution. And on the other hand, we can also use the numerical methods, which is called as finite difference. Okay, finite difference method to solve these three different equations. Okay, three different PDE equations. But since this is a numerical method, what we obtain is just an approximated solution. Okay, approximated solution, and there will be some error. Okay, because of this is just an approximation compared to the exact solution. Okay, why we need the numerical methods? Okay, actually, in most of the real life problems, where to model the real life problem, we will tend to simplify the problem in simple geometries with simple thermal conditions. Okay, so because of this, there is always a tendency to oversimplify a problem into mathematical problem. Okay, because we want to learn an analytical solution. Okay, so this, if we can use the numerical methods to solve the mathematical model, okay, then the mathematical model, it could represent the actual problem better. Okay, because we don't oversimplify. Okay, we still simplify, but not oversimplify the model. Okay, so in engineering problems, sometimes it requires the extensive parametric studies. Okay, this parametric studies means if the parametric is changed to another value, then how it should affect the output. Okay, that is the parametric study. So normally, when it requires the extensive parametric studies, numerical method will be better. Okay, will be easier. Okay, these are the formulas that you are going to use for finite method, and the formula will be given in the appendix. Okay, appendix. So you have to know how to choose which one to use for your model. Okay, now we look at this heat equation. Okay, this is what you have learned. This one. You are given the heat equation and the length of the rod is A, and you are given the boundary conditions where the starting point and at the end point, the temperature is 0. Okay, and initial condition, you are given the initial condition. So by using the forward difference and central difference formula, we can approximate this one into this form. So how we get this? You see, this is first order in T. This is second order in X. We use the forward difference. Okay, forward difference. Okay, so the U in terms of del U del T, we choose this. Okay, and del square U del X square, because we use the central difference. So we use this. Okay, del square U del X. So the one for the second order, we will take from the central difference formula. Okay, and for the forward and backward, they are all in first order only. Okay. So in the questions, it will mention, okay, forward difference, backward, or central difference formula. Okay, so you just take the suitable one. Okay, so that's why this one can be changed into this. Okay, so if you look at this equation, we have K and H. K is the changes in T. H is the changes in X. Okay, that means the step size of X and the step size of T. Okay, your X is given from 0 up to 8. Okay, 0 up to 8. So we will break this into a number of subintervals. And same goes to the T. Okay, you are given an interval of T and we will break it into a number of subintervals. Okay, this one, it depends on the questions. Okay, depends on the questions. What is the value for K and H? Okay, now we look at the first example. Find approximate solution. Okay, this one with boundary conditions and also initial condition. Okay, this one we are finding for approximate solution, meaning that we solve using this one. We solve using finite difference method. Okay, and if you use finite difference method, this one is not necessary to be any other values. Okay, this one, and this one can be any other values other than 0. Okay. Then by using forward and central difference formula, okay, given H is 0.25, K is 0.05. So this is the first step. Okay, step 1, we will sketch the grid points. Okay, just now your X is 0 up to 1. T is 0 up to 0.1. This one, and your H is given as 0.25 and K is 0.05. We will take the x-axis for X and the one for Y. Okay, we use for T. Okay, X versus T. So your X starting from 0 up to 1. This one, 0 up to 1 with a step size of 0.25. Okay, 0.25. From T, 0 up to 0.1, this one, 0 up to 0.1 with a step size of 0.05. Okay, 0.05, this one also 0.05. Okay, so this is the first step. We will sketch for the grid points based on the given X and T intervals and also the. Then next, we will compute for the boundary and initial values. Okay, so this is the given initial condition. Okay, so this one, 0, that means T will remain 0. Okay, T will always remain 0. Your X will be all this value, 0, 0.25, 0.5, 0.75, and 1. So your X are these values. Then you have to get the right-hand side values by substituting the X value into here and here. Okay, that means when X is 0, 0. When X is 0.25, this one is 0.25, this one also 0.25. So you use your calculator to compute to get this. Okay, and since your X value, this is the angle, right? Angle, and this one we use radian. Your calculator, okay, you use radian mode because there is no degree. There is no symbol of degree for the angle, so we use radian. So you just substitute the 0.25 into this one X and this X. If you get this. Okay, so same goes to the rest of this. Okay. Then these are the boundary conditions. Okay. The one starting point 0 and the X ending point is 1. Okay. So 0 means it will always be 0. But T we have 3 values. 0, 0.5, 0.05, and 0.1. We have 3 values for the T. Okay, same goes to this one. But since the right-hand side is 0, that means no matter what is your T, it will remain 0. Okay, this one it will remain 0. Unless if you are given a function in T, then this will change accordingly, according to your T values. Okay. Any questions so far? Okay, if no, then next one, we will fill in the into the grid. Okay, so from the grid just now, this one, we will fill in the values of all this. Okay, so these are the points. U00 is 0. So that means this is the point. U00 is here, 0. 0.250 is this. So 0.25 and 0, that means it's referring to this point. So for this point, the value is this one. Okay, and so on. We will fill up for the values of this. This is the initial condition. Okay. Initial conditions will give you the values for this first row. And the boundary conditions, that means here, 0, 0, 0, 0, 0, 0. Okay. Because 0, 0 is still 0, 0, 0.05. This means it's referring to this point. 0, 0.05. This means this point. So this point, the value is still 0. So boundary conditions, basically, it will give you the values of two vertical. Okay, the first vertical and the last vertical line. Okay, then we will label. Okay, we will label the internal points. There are 6 internal points. Okay, there are 2 ways to represent the point. Okay, one is UXT. These are UXT, and another one is we can use UIJ. Okay, UIJ. This means you put the index of I and index for J. Okay, starting from 0, 0, 1, 2, 3, 4. This is for I. And 0, 1, 2, this is for J. So meaning that, let's say for this point, we can name the point as U 0.25, or another name is U10. 2 different names for the points. Okay, all of the points we can either name it using UXT or UIJ. If UXT means that you're referring to XT. If you use UIJ, let's name this one IJ. But when we label the internal points, we will use IJ. Okay, we use IJ to label point. That's why for this point you have 1, 1. For this point, this is U2, 1. And so on. Okay, so after you fill up the initial values and boundary values, you fill up you label the internal points. Okay, next we have to find for the values of all these internal points. So we have to come up with the formula first. Okay, this one, we have to obtain the formula of Uij plus 1. So according to the questions, we have to use the forward difference and central difference formulas. Okay, this is your PDE. This is your heat equation. So we discretize it first. Discretize means we put an I, j. Okay, I, j for these 2. Okay, this one and this one. And this one, okay, you can either leave it on the right or you move it to the left. Okay, then we will find for the corresponding formula. Okay, forward and central. This is second order, this is first order. So this one you will choose from the central difference. Okay, central difference, del square U, del x squared. You will use this formula for this one. And this one, we use the forward difference, which is this formula. Okay, so once you have identified the formulas to be used, substitute the formulas into the PDE. Okay, substitute 2 formulas into your PDE. Okay, and next we will try to simplify. Okay, we will try to get a formula. Okay, here you will see all different Uij plus 1, Uij, Ui plus 1j. This is Uij, which is same as this one, and Ui minus 1j. Okay, there are 4 different U. So this one, if you sketch all 4 different U's into the grid, this is how it looks. Okay, we sketch like this. This is J. Okay, this is I. Okay, I. So if this is I, that means the next next column will be I plus 1. Okay, and previous column, this one, it will be I minus 1. Okay, if this is J plus 1 will be one row above. So Ij. So we sketch one by one for this 4 different U. Okay, we want to know what is the position of the U. We have to know which U will be chosen to split for the formula. Okay, at the end we choose this Uij plus 1. Later I will explain to you why we choose this over the rest. Okay, now we sketch this one first. Uij plus 1. Ij plus 1 meaning that I and j plus 1. This means this is the point. Uij plus 1. Uij. Ij. This means this is Uij. I plus 1 j. I plus 1 and j. This means this is the point. And the last one, Ui minus 1 j. The point is here. I minus 1 j. So you see the position of these 4 different U. Okay. And look at this once again. These are the values that we have already got. Okay, we have obtained these points. We want to find for the internal points, which is one row above. Okay, one row above. So based on this one, okay, we know that we can find for Uij plus 1 given the values of these 3 U. Okay, if you have these 3 U values, you can find for this one. Okay, this one. That means if you want to find for U11, we just need these 3 values. If you want to find for U21, we need these 3 values. Okay, and U31, we need 3 values. Okay, that's why we choose this Uij plus 1 to lead your formula. Okay, now back to this. This Uij plus 1, that means we want this. We want this. So now we want to rearrange this equation in such a way we want only this stay on the left. Okay, so how to simplify this one? Okay, this one actually you don't have to move to the left. You can leave this initially on the right hand side. Okay, this one leave it on the right. Okay, this means you have something like this. Okay, 0.5. You have 0.5 here. You have k. You have 8 squared. Okay, so this one it means this one when you move to the right, and you move the k to the right hand side. So you have 0.5k. Okay. I repeat once again, this term, move this to the right hand side, and you move the k to the right hand side. That's why you have 0.5k. And you factorize the h squared, you have 0.5k over h squared multiplied to this 3. Can you see that? Okay, then this one, we move it to the right here. And since you have the k and h values, so you just substitute the k and h values given by the question. Okay, so here that means you have 0.4. After you calculate, you have 0.4. Okay, and this Uij is the same with this Uij. So we can expand. Okay, that means this 0.4, we open the bracket, and then we combine this with this one. Then you get this. Okay, 0.8, okay, negative 0.8 plus 1. Then you get plus 0.2 Uij. Okay, so now we get this formula, then we can start to find the values of the internal points. Okay, up to this point, since why we have to choose Uij plus 1? Because we have the values. If you look at this one, we have the values here. And we want to find for the internal points, which is one row above it. So if you have, okay, this one, since you have this, the values of this, that means you can find for this one. Okay. So that's why this is the one chosen to lead for your formula. Okay. Okay, any other questions? Okay. So once you have get this formula, we will start to get the values of the input points. Okay, this is the first value to be defined. U11. So this one, if you compare this with the formula Uij plus 1 with U11, that means I is 1. Your J is J plus 1 equals to 1. So your J is 0. So I is 1, J is 0. When you substitute 1 into I, 0 into J, it's 1, I and J. You see all the IJ here, then you will get this. Okay? And this U00 means this one. 0, 0, this one. U10, 1, 0, that means this one. 2, 0, 2, 0, that means this one. Because J plus 1 equals to 1. You match this one with the internal points. Okay, we want to get their corresponding I of J. Okay, so actually without this 1 and 0, if you know the sequence of this, basically you can substitute the values of 0 into the first one, this 0.2310 into the second one, and this one into the third one. This one, 1, 2, 3, because you have already arranged all the U in the order that you want. If you didn't arrange this, of course, this one, if you didn't arrange in this way, later you still can find your answer, but you have the values here, you have this value, maybe you do not have this value, but this one is given, then you just rearrange. But if you arrange your formula first, it will be very, very simple later. Okay? Because we know that to get the point, the first, second, third U will be this 1, 2, 3. To get the U21, you need the point, this one, and this one. 1, 2, 3. Okay, the work will be very simple later. If you arrange your formula in this according to this sequence. To get this, you need these 3 points. Okay, but of course, if U21, if you match with this one, I is 2. J plus 1 equals to 1. Okay, J plus 1 equals to 1, meaning that J is 0. I is 2, J is 0. So when you substitute I is 2, J is 0 into all the I, you will get this. Okay, and these 3, they will confirm referring to these 3 values. Okay, then you get your U21. Then next one, U31. Okay, U31. So you can see here, you need this 1, 2, 3. 3 points. Then you get 0.1988. Okay, so once you have settled this, we will proceed to find for U12. Okay, so once you have get the internal points value, you update into the grid. Okay, put it into the grid. Okay, then we find for the U12. Okay, U12 still, we will use this 1, 2, 3 here. Okay, and U22, 1, 2, 3, these 3. And U32, that means 1, 2, 3. So if you match this one, for example, this one, if you match 3, 2 to this Uij plus 1, means I is 3. Okay, I is 3. J plus 1 equals to 2. That means J is 1. I is 3, j is 1. When you substitute these two values into I and j, you will get this. And U21 for sure, U21 will be this one will be this one, U31 will be this one, and U41 will be this one. Okay. Once you have find the U value, internal point, you just update into the grid point. Okay, so your final answer will be this one. This is your final answer. Okay, any questions? Okay, no questions. We look at the second example. Okay, find the approximate solution for this condition. Okay, this one also 0. Okay, you have the initial condition. Now we are still using the forward and central. Okay, given h is 0.5, k is 0.1. Okay, so x 0 up to 1 with a step size of 0.5. So you have three x value, 0, 0.5, and 1. And for your t, 0 up to 0.4 with a step size of 0.1. That's mean 0, 0.1, 0.2, 0.3, 0.4. Sketch the grid. Okay, sketch the grid. And then you label the j index. Then calculate for the boundary and initial values. Okay, so x, you have only 3 values. T, you have 0 up to 0.4 with a step size of 0.1. Okay, T will change accordingly. But if you see a constant, that means it will always be a constant, no changes. Okay, since all 0, that means all 0. If this is given as 1, that means all will be 1. Okay, it depends on the questions. Okay, and this one, since you have 3 different x, you have to substitute these 3 different x into this x to get their corresponding right-hand side value. Okay, then substitute all these values into the grid. Okay. And here all 0, all 0. Label the internal points. Okay, this one is U11. This one is U12, 13, and 14. And next, we find for the formula. Formula, since we are using the forward and central difference formula, that means this is same as the one, as the example number 1 just now. Okay, so after you have identified what is the formula to be used, okay, just substitute these two into this. Okay, this one, move it to the right. Okay, you can usually let it be stay on the right hand side. Okay, no need to move to the left and to the right again. Okay, then k, you move it to the right. That means 0.1 times k. Take out the h squared. So you have 0.1 k over h squared multiplied to this bracket. Okay, then move this to the right here. Substitute the k and h. Simplify, you get this value. And then open the bracket, combine these two. Okay, this one multiplied to 0, 4, and then plus 1. Get this. Okay, once you have get your formula, you can start to find for your internal points. Okay, so to get this one, first 1, 2, 3. This 3. Then you get this. Okay, this is the 1, 2, 3 that I'm referring to, the first U. Okay, then to get the U12, you use this 1, 2, 3. So whenever you have found the U, you just put the value, update the value into the grid. It will be easier for you to refer. Okay, and to get this one, we need this 1, 2, 3. Okay, and to get the last one, 1, 2, 3. Just substitute the values accordingly. Then you will get the final solution. Okay, basically this one, normally all of the students manage to score. Okay, except some careless mistakes in the calculation. Okay, students manage to score. Okay, so this is coming out in the final exam. So I hope all of you 100% understand this one and manage to calculate for all the values. Okay, now try for this exercise. Okay, sketch for the grid point first. Okay, sketch for the Okay, sketch the grid points. One over 5 is 0.2. 1 over 100 is 0.01. Okay, sketch for the grid point first. The grid point, the grid, make it big enough for you to insert all that. Really, on the important operators, all must be important operators. So your x from 0 up to 1 with a step size of 0.2. and your t from 0.0 from 0 up to 0.0 it could be the set size of 0.01, which means you have only 3 values. And label the indexes of I and j. Compute for the values of boundary and also the initial values. Okay. So you have all this for your x values. Compute the right hand side values accordingly. Compute for all the boundary and initial values and fill up into your prefix. So calculation must be in 4 decimal places. The first one is 0. The second one 0.16. This one 0.24. 0.24. 0.16. That means it is symmetry. Yes. So all these are 0. Put the values into your tree. Then label your internal points using the one item change. Label the points. So your internal points, this is U 1 1, 1 comma 1. So U 2 1, U 3 1, U 4 1. Okay. This is U 1 2, 2 2, 3 2, and 4 2. 4 2. My grid is quite small because the whiteboard is small. Okay. Okay, next one, we have to find for the formulas. According to the question, we need to use the forward and central difference formula. Okay, forward and central difference. So, one, forward and central. Okay, one, UXX, we use this one. Okay, UXX, and the UT, we use this. Okay, so we substitute these two into the PDE. Okay, your PDE just now is del U del T equals to del U del X squared. Okay, so you use the two formulas here. You can discretize this Ij U formula A plus 1 minus Uij over K. Okay. Next, we will move the k to the right. We want this to stay on the left. Okay, uij plus 1. Okay, k, bring it to the right. Okay, when k goes, it goes up over h squared. Substitute the k and h, and at the same time, you can bring this right. K is 0.01, h is 0.2. Okay, then to bring this to the right, it will be plus uij. Then simplify. Okay, any questions so far up to this point? What is the value that you obtain? 0.25. Okay, 0.25. Okay, then we will open the bracket. Okay, so 0.25 multiplied to each of this. Then this one will be combined with this. Okay, so 0.25 for the first one. Okay, 0.25 times -2. Okay, times -2, that means negative 0.5. Okay, negative 0.5 plus 1. So plus 0.5 uij. Okay, again, 0.25 multiplied to this -2, you get a negative 0.5. Negative 0.5 uij. Then the negative 0.5 uij plus 1 uij, this means positive 0.5. Okay, so you have to multiply, then this one, after the multiplication, combine with this. Okay, so this is your formula. This is the formula. So we will find, starting from the row above the initial. Okay, the same we will start from here. Find for this one, this one, this one, this one, then followed by this one. Okay. But this one, okay, you proceed first. Okay, proceed first. Find for the all this. U11. U11. So how to get U11? 0.25 multiplies U11 is here. So 0.25. The first U is this one, right? Plus 0.5. The second U is 0.16 plus 0.25. The last U is 0.24. Okay, 0.24. Is it? When you find for this one, you just need the 3 points underneath. 3 points underneath. Okay, according to the grid that is sketched for the 4 different uses now. Okay, you know the position. Then it will be simple, very simple. Okay, so this one, U11, you get U11 is 0.14. Do you get 0.14? I is 1, right? Yes, I is 1. So I plus 1 is 2. You know, to I big 2 of J big 0. Okay, if you use the IJ, what is your I? I is 1. J. What is your J? 0. 0. Because J plus 1 equals to 1. Then your J is 0. So when J is 0, okay, you get this one. This says I is 1, that's 2, 0. This is 1, 0. 1, 0. This is I minus 1. 1 minus 1, 0, 0. 0, 0. So, oh, this one, just now we forgot to put the 1, I minus 1 in front. Forgot to put the I minus 1 in front. Remember the sketch just now? I think I hit 1. J plus 1. I plus 1. I minus 1. So we have to choose the one, this one first. This one first, then Uij, then this one should be the last. Okay, this should be the last. Okay, so here we make one more line. Okay, so among these 3 U, this one first, I minus 1J plus 0.5 Uij plus 0.25 Ui plus 1J. This one, the second one, this one, the first one, this one, the last one. Okay, because of this. This one is the first, second, and the third. Okay, so back to our formula. This is your final one. Uij plus 1. Okay, this is your formula with the correct sequence. Okay, with the correct sequence. I minus 1, I, and I plus 1. Follow this sequence. Okay. Do you get what I mean? This one, the sequence of the U. Yes. The sequence of the U is important, okay, because if you didn't use this way, okay, you use the you take the three values directly, you have to make sure your U is in the correct sequence. Okay, otherwise you have to use this one. You have to check one by one. Okay, this one takes time. When we use this I and J, you identify the I and J, and then you substitute all the IJ, then you get the corresponding U, then only you find for the U. Compared to we just take the three values directly, that is much easier. But your U must be in the correct order. Okay. Next, we have to find for U21. 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 So you have get the U11 substitute into the grid 0.14. Then find for U21. Okay, U21. So U21 is here. So the three values will be 1, 2, 3. Zero point double two. Okay, do you get 0.2? So you just fill out, then find for the next. U31, U41. So U31, you use these 3 points, 1, 2, 3. Okay. Once you have done U41, then proceed to the one more row above. U12. U12. We use this 1, 2, 3. Okay, have we done? Okay, this one. If you look at the screen, this initial condition, initial value, and boundary values, they are symmetrical, right? They are symmetrical. They are symmetrical about the line x equal to 0.5. We can also use a sentence like this: boundary and initial condition are symmetrical about the line x equals to 0.5. Okay. Boundary and initial values are symmetrical. Symmetrical at x equals to 0.5. Okay, x equals to 0.5. So that means your U11 will be equals to U41. U21 will be equals to U31 because it is symmetrical about the x equals to 0.5. Okay, that means all the internal points will be symmetrical as well. Okay. So hence, U41 will be equals to U41 equals to U11. U31 equals to U21. Then 42 equals to 12. 42 equals to 12. And 32 equals to U22. Okay. That means you just need to find for 4 internal points. Then you just substitute the values directly into the grid. So the condition of the boundary and initial, it must be symmetrical in order for you to use this. Okay. If it is not symmetrical, that means you have to find all the internal points one by one. Okay, any questions? Any questions for question number 1? Okay, now we look at question number 2. Okay, number 2. Which one? Okay. Okay, have you get your initial values? Okay, 0.5, the one for 0.5. What is the value for this one? 0.041. 2.1213. 2.1213. You have to use radian. Radian to find. Okay. 1.0. Three. Next one. 2.1213 again. And this one, sine phi is 0. Okay. So this one, your t, you have 3 values. Okay, all 0. Zero, 2.1213, 2.1313, 3. This one is 3. Okay, so symmetrical. These boundary conditions and the initial conditions are symmetrical. Boundary and initial condition are symmetrical above the line. What's the line? Right. X equals to 1. Okay, x equals to 1. That's mean? That's mean? Your U31 equals to U11. And your U32 equals to U12. So how many points you need to find? How many internal points you need to find from the formula? 4. 1, 2, 3, 4. Forward and central difference formula. And you're using the same one as just now. Forward and central. What is the K just now? 0.03. 0.5. 0.5. 0.5. 0.03. UXX. So we move the k to the right, factorize the h squared. Zero point zero three k over h squared. Substitute the k and h, move the uij. So this one get 0.06. Then decide who's the first, the second, and third. Take negative 0.12 plus 1. 0.88. 0.88 uij and 0.06. The last one is ui plus 1. Then you can start to use this to find for your U11. U11, we use this 1, 2, 3. The U11 is 2.0467. If you follow 4 decimal places, this one, the final answer in the slides, I think I generate using Excel. That's why it's slightly different. So that's it. Your U31 is also 2.06 and 0.76. And we find for the row of j equals to 2. Then the last one is U22. U22, we use this 3. Okay, any questions? Okay, let's have a look at some partial questions. Okay, this is the question from last year. Okay, so you see this, okay, but this one is the wave equation. Okay, we will look at the wave equation solving and next week. Okay, next week. But the steps are almost similar. Okay, it's just that it has an extra of this initial velocity, this one. Okay. So you see, you are given the PDE, boundary initial conditions identified. Okay, whether the differential equation is hyperbolic, parabolic, elliptic. Then, given H and K based on the boundary and initial given conditions given, construct a mesh of discrete points. That means the grid. Okay, this one. Hence, find the values, compute for the UXT. Okay, by using explicit finite difference method. Okay, the method that you have done today is called finite difference method. Okay, 23 marks. Okay, last 2 years. Okay, this is a heat equation. Okay, heat equation. Initial temperature function. Okay, this is the initial temperature function. This is the boundary conditions. You see, find the approximate solution of the heat equation by using forward difference and central difference formula. You are given H and K and work the solution in 4 decimal places. 18 marks. Okay, 18 marks. And the part B is given the exact solution of the heat equation. Okay, you are given this model and you find for the approximation using the finite difference method. But if you are given the actual solution, meaning that you can find for the error. Okay, you can find for the error. So this one, since this is the solution, you can find for this. Substitute x by 0.5, t by 0.04 into this using a number of non-zero terms. Then you will get an exact solution. And from the exact solution, compare with your approximated solution, find for the relative error. If the relative error is more than 50%, that means That means your solution from part A is rejected if more than 50%. Okay. If less than 50%, that means your solution of this from part A is accepted. Okay, this is what it means. Okay. So that means you just find for the actual solution of this one from this series, then compare with your solutions here for this particular point only. For this particular point. Okay, if the relative error is more than 50%, then you give your justification, your solution at this one from part A is rejected. Okay, something like that, if more than 50%. Okay, last 3 years, this is weight, a heat equation. Heat equation. Okay, then show whether this is hyperpara or elliptic. Okay, we describe graphically and explain how 4 points are used to generate the finite difference formula for the heat equation. Okay, this is what I explained just now based on the j plus 1, I minus 1, I plus 1. Okay, then this one solve this numerically, given h and k. Okay. So basically, this one is simple. Okay, this one is simple. Okay, if you know how to solve this numerically. Okay, so next week we will look at how to solve wave equation using finite difference method. And after that, that means we have done the syllabus. We will have one more class to complete the syllabus of this course. Okay, that means next Tuesday. Okay, next Tuesday. Okay, I will see you next week. And revision class, maybe during revision week or before the revision week, I'm not sure. This one depends on the Jordan Wasser MTC. Okay. Let you know the date in the WhatsApp group.